All right, Ivy. Tonight is going to be two-part notes. We are going to start off with talking about the Pascal's triangle and the binomial theorem, and then we're going to go into binomial distribution. So everything is binomial tonight. Before we get started, though, we showed you guys in class how to go to Stat, Edit, and enter your data. Make sure that you're familiar with this if you haven't already written down the keystrokes so you guys remember where to go for different statistics to enter so that you can do the mean and standard deviation in the calculator. Make sure you know how to do that. And then also, we're going to be using today the combination. So if you go to Math, Probability, the third one is NCR. And I know last year you guys did permutations as well. We're going to focus on combinations today. And your screen will look like NCR. That's what's going to come on your screen. But you're going to have to put in what your total is first, and then NCR, and then how many you're choosing out of your total. So this would be 6 combination 3. I believe you can also put NCR and then parentheses 6 comma 3. That's another option. But this is a straightforward way to do it. So just make sure you guys are familiar with both of those before we start. So pause here if you need to practice. All right, so part 1, Pascal's triangle and how that has to do with probability. So take a second. If you are forgetting what Pascal's triangle is, it is a triangle where there are ones that line the diagonals, and then each row is starting with a 1, but then you take the two numbers above and you make a sum, and that's the number in the next row. So we'll have 1, 2, 1, 1, 3, 3, 1, because 1 plus 2 is 3, 2 plus 1 is 3, and then here we have 1, 4, 6, 4, 1, and you guys can keep going forever and ever. But this is Pascal's triangle, and one of the interesting characteristics of it is that it gives us our coefficients when we're doing our binomial expansion, which is what you guys spent some time on last year. So for example, if you just did a plus b, so a binomial, it has to be two separate terms added or subtracted, and then it's raised to a power, usually referred to as n. N is our power. N can start with 1 and it'll go up forever. It can actually start with 0 as well, right? So anything to the 0 power is 1, and that's where this first number is coming from. So now when n is 1, we're looking at the first row right here. So if this is n is 1, what we're really saying is that the coefficient for a is 1, a, and then our second term is also a coefficient of 1, and that's the b. So that's where our coefficients are coming from. What's going to happen is if we do a plus b squared, right, we know that is a squared, and then we have plus 2ab in the middle, and then we'll have plus b squared. What you'll notice is that the first term, so for us the first term is a, it will start with the highest exponent, which is n. So it'll start with this 2, which is also the corresponding row. Okay, remember we start with 0, 1, 2. So 2 is our exponent, and a squared, first coefficient is 1, and then plus 2ab. So a has now dropped by 1 exponent. A is now to the first, whereas b has now appeared. That's because in the first term, b was raised to the 0 power. Now it's to the first. And then in the last term, b is to the second, and a has disappeared, and that's because a has now dropped to the 0 power. So our first term starts with the highest, the n, the highest exponent, and it drops by 1, whereas our b value, our second term, starts at 0, and then it increases by 1 exponent, 1 degree. And then it will go to the when n equals 3. So we'll look here, and it looks like the fourth row, but again, remember we start with 0, so this is 0, 1, 2, and 3. So we have 1, if we take our first coefficient, 1, and a starts with 3, b starts at 0, so really that b to the 0 is just 1. And then we'll add, we have 3 as our next coefficient, a is now to the second, b is now to the first, and then we'll have 3 again as our coefficient, a to the second, b to the second, and then our last term we have 1 as our coefficient, whoopsie, there we go, a to the first, excuse me, a squared, a, and now a is to the 0 power and b is to the third. All right, so same deal. We'll do one more row with the fourth. So we have 1, a to the fourth. We've got b to the 0, so that's really not even there. Then we have 4 as our coefficient, a to the third, b to the first. And then we have 6 as our coefficient, a to the second, b to the second. They're the same. Then we have 4 as our coefficient, a to the first, b to the third. And then our last term will be coefficient of 1, a to the 0, and b to the fourth. All right? So our a term again starts with n, whereas our b term ends with n, okay, as our exponent. So our expansion is really in the form of whatever the first term is plus the second term. N is our exponent, and n will continue. All right? N can be any real number. But if you guys notice, again, we kind of talked about the pattern. A starts with n, and b increases and ends with n. How many terms are present? We kind of touched on this as well. So if n is 4, if we look at this last example, we actually will have 1, 2, 3, 4, and 5 terms. So we have 5 terms because really we're looking at the rows of the Pascal's triangle. We're on the 5th row. So depending on what your n is, how many terms you have is actually n plus 1. All right? Now, why does this relate to probability? I believe you guys touched on this last year as well in SL. If you guys think of combinations, what we're really saying is that we are on the 0 row, right? And we're choosing 0 possibilities. So we have 0 possibilities out of 0. How many ways are there to choose that? There's only one way to choose 0 out of 0. So if we, again, go to the second row, we now have 1 and we're choosing 0, or we have 1 and we're choosing 1. Again, if you have one item and you're choosing none of them, there's only one way to do it, which corresponds to this one up here. And if you have one item and you choose one item, there's only one way to do it. What you're going to notice, though, is as we continue, so now we are at n equals 2, and we are choosing 0 first, and then n choose 1, n choose 2, right? As this continues, you're going to notice that we're going to get more combinations, and they correspond to the Pascal's triangle. I'll do one more. So 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. Okay, so there are, and you guys can list these out as well. There's one way to pick 0 out of 3. There are 3 different ways you can pick 1 out of 3. There are also 3 different ways to pick 2 out of 3. And there's only one way if you pick 3 out of 3. You got to pick them all at the same time, right? So these characteristics and the way that these match up, that really is going to help us when we're starting to find different terms of the binomial expansion. So in layman's terms, in general terms, when you guys are looking at your packet, this is what you guys are given. You guys are given the binomial theorem as this right here. And all this is saying is that when you see this n in the parentheses, and then the r is really what you're going to call it, whatever you're choosing, that is the same as when you see the combination n choose r. Okay? So again, n is whatever exponent we're starting with, whatever the degree is. A always starts with that exponent. B always starts with 0. And then our coefficient will change as we go. And eventually at the end, our a will now have an exponent of 0. It'll go all the way down, and b will have the exponent of n. All right? So n choose r is really the same as your combination of n items choosing r to make that coefficient. And your term is always going to be n minus r. That's going to be what your a term is, and b is going to be on the r. All right? And again, r and n are any real number. And r is smaller than n because n is the highest you guys can go to. All right? So these are the basic setup. What I'm going to ask you guys to do is go ahead and pause here. Try to expand 2x plus 3 cubed, x minus 2 to the fourth. Be careful here. You have to think of this one as x plus, and then think of negative 2 as your b value. All right? Be careful with that one. Anytime there's a minus sign, the minus has to go with the b term. And then also, for this one, it's to the 12th power. We're not going to be listing out all 12, but there several IB questions will ask you guys to list out like the first couple terms and the last couple terms. Go ahead and pause here and see how you guys do as far as using the new binomial theorem formula that we're talking about. Check that you did 1 and 2 correctly and that you see the pattern. Go ahead and set up number 3, and we're going to look at this one in class next time. So out of the binomial theorem, if we just want to find one term and not list them all, what we're really looking at is T stands for term, R stands for which section you're on, which term you're on. But since you have one additional term, we also have to do the same for our R. We'll have to do, it's really the R plus 1. So depending on what you actually are looking for. So for example, if we want to find the 7th term, we're going to use R as 6 because R plus 1 would make our 7. So therefore, if we want to find the 7th term of this one, we would say term is really going to be 6 plus 1. So that means our R is going to be 6. We have 14 as our N. We have 6 as our R. Our A value is 3x. And we are going to raise 3x to the n minus r. So that's going to be the 14 minus 6 as our power. And then we'll take our b value, which is negative 4. Remember to include the negative. And that's just going to be raised to our r value. So what is really happening here is we're kind of taking a snapshot of one term in our sequence. And of course, we would simplify this number, 14 choose 6, combination 6. We would also make sure we raise our 3 to the 8th power because that is going to wind up becoming part of our coefficient, and also negative 4 to the 6th power. So all those numbers multiplied together is going to make our new coefficient. So for example, in number 2, when it says find the coefficient of x to the 7th. All right, so what we really want here is we're not quite sure which term we're talking about, but we do know that we want the x to be raised to the 7th power. So this one's a little different in how we're going to set it up. Since we're not sure what term it is, we're going to keep r as r so we can figure out what term we're talking about. We're going to go ahead and put in everything we do know. So I do know that n is 11. I do know I want to find r. I'm not sure exactly what term we're on. I know my a value is x squared. And I know I'm going to raise that to the 11 minus r. And then I also know that 4 divided by x is going to be raised to the r power. So if I'm thinking about x to the 7th, what I'm really wondering is, well, here's my x, so this is going to be affected. And this x down here is also going to be affected. So let me simplify this a little bit. 11 choose r. And now I have... I can actually say x to the 22nd minus 2r if I distribute that to 22nd. And then I also have 4 to the r over x to the r. Since I know that this 4 to the r is going to become part of my coefficient, I'm actually going to move it. And I'm going to put 4 to the r. There we go. Up front with the 11 choose r because those are both going to be part of our coefficient. And then this x to the 22nd minus 2r and divided by x to the r. This is going to really be where my exponent of 7 is going to come from. Remember when you're dividing bases, we subtract exponents. So really what we're looking at is 22 minus 2r minus r is really going to be what our term is. So we're really just simplifying but using a variable along the way. So this is going to become x to the 22nd minus 3r. And what I want is I want this exponent to equal 7. So I'm going to do a little side work over here and I'm going to say 22 minus 3r, I want that to equal 7. So in order for that to happen, I'll have negative 3r is equal to, let's see, negative 15. And then r is going to equal 5. You can also find which term you're talking about if you just kind of start to expand it, but saves you a little bit of time because you're not sure what term you're going to actually be on. So of course now, since I know r, I can substitute r back in and I'll be able to find the coefficient for this problem.